In this video, we are going to convert a normal X and Y coordinate into a polar coordinate. All right, and it's very much visual. It's very much pulling on to some prior knowledge that we've done in previous videos. So here's what we got. Let's create a visual. And remember that a polar coordinate consists of an R and a theta. So we need a distance, aka a magnitude, and we need an angle, right? That's our direction. So we're taking that and converting it into this. And both of them will get you to the exact same location. Okay, that's the idea. So our picture is we're going to go out 3, 1, 2, 3, and up 4, 2, 3, 4. And this is our point. We are drawing a distance in here. So that is going to be our radius. Also, if you want to think of it as a vector, this is our magnitude. All right. And then we are going to be looking for this angle. The angle is always made up of wherever this ends in the x-axis. Okay, so the first thing that we're going to do is let's label our triangle. It's out 3, it's up 4, and if I want to figure that out, that's a Pythagorean theorem. So I'd have 3 squared plus 4 squared is going to equal the radius squared. That's a 9 plus a 16 equals r squared. That is a 25 equals r squared. So if we square root, r is equal to 5. Okay, so we have a distance out. Perfect. All right, so let me cut that off. So the next part of this is we need this angle right here. Now I'm going to try to avoid using a value that I just found, just in case that's wrong, then it guarantees my angle is going to be wrong. So I'm going to try to focus on just the 4 and the 3. So this is going to pull back trig information. SOHCAHTOA. All right, so from here, we have an opposite side and we have an adjacent side. So that would be a tangent. So I want to set up my equation as a tangent of an angle we don't know is going to equal 4 over 3, opposite over adjacent. And the only way for me to figure out an angle measurement is for me to do the inverse. So inverse tangent of 4 over 3 is going to get me a certain angle that I have no idea. Let the calculator do this. So an inverse tangent of 4 divided by 3 is 53.1 degrees. So that angle is 53.1 degrees. So our coordinate is 5, comma, 53.1 degrees. So the idea is that we would be out 5, but you would be rolling it up, like here's the other 5. So we would be part of a circle, is what that would be. And so we would be out at a distance of 5, but then we would be up 53 degrees, which would kind of bring us in towards that height of 5. All right. So us going X and Y, we're going out 3, up 4 is the same thing as us going out a total distance of 5, but then kind of rolling it across this, keeping that distance of 5 and going up 53.1 degrees. Okay, so let's do the next one. So the next one is we're going out 5, up 8. So for our picture, let's go here. 1, 2, 3, 4, 5, 8. All right, so there is our triangle. We're out 5, we're up 8, and our angle we don't know, and our distance out is there. So just like before, if we're figuring out the radius part, we're figuring out Pythagorean. We're going to use Pythagorean theorem. Same thing, we're going to be converting this into a radius and a theta, a distance and an angle. So 5 squared plus 8 squared equals our radius squared. And then that's 25 plus 64 equals radius squared. So that adds up to 89. And then we square root. So our radius, if you plug that into a calculator, the distance out is the square root of that 89, which is 9.4. So 9.4. Right. So finish the other by circling. So far we're sitting at a distance of 9.4 out. And then how many degrees would we have had to have rolled to get to that spot? So that is back to SOHCAHTOA. And we're still going to use tangent because we still have the opposite and the adjacent. So we're setting that up again as tangent of our angle is going to be opposite over adjacent. To find an angle measurement, we are going to do the inverse of that fraction. And don't know, we're going to do inverse tangent of 8 divided by 5, and that is going to get us 58 degrees. So 58 degrees. Okay. So that is the polar version of the X and Y version. Is this would go right 5, up 8, but that's the same thing as going out a distance of 9.4 and then kind of rolling it around as if that's one big circle with a distance of 9.4 up 58 degrees. All right, so that was converting a rectangular coordinate, which is just a normal X and Y, and converting it into polar, which involves a distance out, magnitude, and an angle measurement.